Hello children, hope you all are doing good at home. We have previously completed one chapter in arithmetic, that is number system, and one chapter in algebra, that is polynomials. So today we shall be learning one new lesson in geometry. You will have been introduced to this concept of geometry or subject geometry right from your lower classes, children. You know what is a point, what is a line, what is a plane, what is surface, how to find the area, how to find the volume of any given square, triangle, all that we have learned. You all know about it. You have been learning it right from the lower classes. So, today we shall know about a mathematician named Euclid. A mathematician named Euclid, children. So, he was a Greek mathematician. Euclid is a Greek mathematician and he gave various definitions in geometry. He gave various definitions in geometry, but unfortunately those definitions were not accepted by the other mathematicians. Euclid is a Greek mathematician and he gave various definitions in geometry. But other mathematicians did not accept his definitions. That is the reason what he did is he gave them or he named them as the axioms and postulates. He named them as axioms and postulates. So you have learned in your lower classes about what are axioms, what are postulates and all. So this axioms or postulates are the truth which is universally accepted, but they are not proved. Such things are called such statements or definitions are called axioms or postulates. What are axioms and postulates? Axioms and postulates was given by the Greek mathematician named Euclid. Why did he introduce this axioms and postulates? It is because he gave various definitions in geometry which were not accepted by other mathematicians. Hence, he named them as axioms or postulates. What are these axioms or postulates? These are simply some definitions or some statements which are universally accepted, but it is not proved. You have learnt about the theorems. So, what do we do when proving a theorem? We prove the theorem. Yes, no? But here for axioms and postulates, they do not have the proof, children. So that is the main thing. Here in your textbook, page number 30, and today we will be studying about his introduction to Euclid's geometry. That is, what are the concepts of geometry that he introduced under his axioms and postulates, that we will be studying in this lesson, children. It is a very short lesson and very interesting as well. Here in page number 30, you have Euclid's definitions, axioms and postulates, children. So I want you to keep one separate unrolled classwork for geometry and write the heading Introduction to Euclid's Geometry. Under that subheading you will write Euclid's definitions, axioms and postulates. So what are the definitions he gave which were not accepted by the other mathematicians? Here they have named few, and I want you to write all the 7 points here in page number 30 in your classwork, children. Soon we shall see what are they. First thing is, see, they have given here a point is which has no part. A point is that which has no part. Yes, no? A point means simply a dot. This is a point now. Amma, ನೀನು ಇದೆಲ್ಲ ಪ್ಲೇ ಮಾಡಬೇಡ, ರೆಕಾರ್ಡ್ ಆಗಿಬಿಡುತ್ತೆ. ವಾಲ್ಯೂಮ್ ಕಮ್ಮಿ ಮಾಡ್ಕೋ. So this is a point. Now simply I'll keep a dot. This is a point now. The first point says what Euclid said is a point is that which has no part. Yes, no? It is just a point, or it is just a, and it occupies only that much space. It is not a part. A line is a breadthless length. A line is a, so what is a line? This is a line. Simply if you draw this is not a line, children. You know, no? You should mention arrow mark on both the side. It means it is continuous. It is continuous. If at all you don't want to draw a continuous line, how would you draw? A straight line with the end points. These two ways you can represent a line. with arrowheads on either sides which says that a line is continuing. If you want to draw a line which ends, then set some points you should show on both the ends. Okay, and yes, so what he said about the line is, a line is a breadthless length. What is breadth? You know what is length, what is breadth and all. Suppose we consider a square, children. So you know how to find the area of the the square. And if you consider the rectangle, also you can find the surface area of the rectangle. What is the formula to find the area? Length into breadth is the formula to find the area of the rectangle. So which is the length? The longest side of the rectangle is called length, and the other two sides are called the breadth of the rectangle. You know all this. So what he is telling is, a line means, see, a simple line it is. It is breadth. It is a breadthless. He says a line is a breadthless length, children. What do you mean by this? Breadthless means, see, it is not broad like this. Yes, no? It is not broad. It is a thin line. So it is a breadthless length. The ends of the lines are points. I said, no, two ways we can represent the line. One with arrowhead which shows it is continuous. The end points, these 2 points are called the end points of the line. Means the line is ending at that point. The ends of the lines are points. A straight line, fourth point is, a straight line is a line which lies evenly with the points on itself. A straight line is a line which lies evenly on points itself. On points. Fourth point is, a straight line is a line which lies evenly with the points on itself. Yes, no, you have studied about the collinear and non-collinear points. Yes, no, children, isn't it? Now, if you join all these points, it forms a straight line. Correct? So, this line consists of number of points on it. So, this line, a straight line is a line which lies evenly on its points on itself. Fifth point, a surface is that which has length and breadth only. Here we consider no example of the square and a rectangle. It has both length and breadth. If at all we want to find the area, we know no formula, length into breadth. That is what he means. A surface is that which has length and breadth only. That is the reason we use the formula L into B in order to find the surface area of these polygons. The edges of a surface are lines. Of course, no. If you consider the square or a rectangle, children, which are the edges? These are the edges. Yes, no. These edges or corners are of course the lines. That is what he mean. Seventh point is, a plane surface is a surface which lies evenly with the straight line on itself. So this is a plane surface now. The example of the square or rectangle, what we have considered, is a plane surface. A plane surface is what? It is a surface which lies evenly with straight lines on itself. Yes, no? The square has 4 sides. All the 4 sides are straight. Straight lines. Those are straight lines. They are not curved lines like this. No, they are straight lines. So any plane surface area means the edges are the straight lines. These are the few points which Euclid gave or which he defined were not accepted by the other mathematicians. But these are the things which are universally accepted, children. That is the reason he named them as the axioms, and it is defined as the axioms, Euclid's axioms. So, but yes, no, whatever we learned now, all the 7 points are true, no, children. One point also we cannot deny. We cannot say it is false. Yes, all the points are true or it is accepted. It is obviously the truth which is accepted. So this was given by Euclid. Next, we shall see or learn about the Euclid's axioms. I already said you what are axioms and postulates. I will add one more point to that, children. What it is means, axioms are the things which are applicable everywhere. Axioms are the things which are applicable all over. Means even in our daily life we can apply these axioms. Means here he has given 7 main axioms, children, Euclid. While giving the example, I will tell you. So everything what we do daily in our life, in our routine, everywhere you can apply these axioms. So these are axioms are the things which are applicable everywhere, but postulates are the things which are applicable only in geometry, children. So postulates are the things which are applicable only in geometry. This point you should keep in mind. So here are the 7 main postulates which are given by Euclid. First axiom says that things which are equal to the same things are equal to one another. So I want you to read and write these all the 7 axioms in your class works. Things which are equal to the same things are equal to one another. What it means is, suppose if I say A equals B and B equals C. If A is equal to B and B is equal to C, so A is B, B is C means this implies A is equal to C, isn't it? I will write here, if A equals B and B equals C, what is it implies? A is equal to C. So that is what he means by his first axiom. Things which are equal to same thing. Here A is also equal to B and C is also equal to B. So here two things are equal to one same thing. Which is that one same thing? That is common point B. A is equal to B, C is equal to B. So A and C are now both equal to B means they are equal to one another. If A and C are both are equal to same letter or point B, then A and C are equal. That is what he mean by his first axiom. Things which are equal to same thing. Which is the same thing here? C, B is the same thing. A is also equal to B, C is also equal to B. So if things are equal to same thing, then they both are equal. Means A and C are equal. That is what he mean by his first axiom. Second, if equals are added to equals, then the wholes are equal. Suppose I take, if equals are added to equals, means two numbers should be equal. I will take 2 is equal to 2. If equals are added to equals, means for both LHS and RHS, what I do is I will add +1. Why? Because he is telling if equals are added to equals. Which are the equals added now? +1 are the equals added to equals. Which are those previous equals? Means 2 is equal to 2. If you add equals +1 and +1, then whole are equal. Whole are equal means what do we get on LHS? 2 plus 1 is 3. What do we get on RHS? Again 2 plus 1 is 3. So 3 is equal to 3 we get. This is what? The wholes are equal. If equals are added to equals, then the whole are equal. That is his second axiom. Third axiom, if equals are subtracted from equals, then the remainder is equal. Similarly, here we added +1. No? Take some other number, say 1 is equal to 1 I will take. No, 10 is equal to 10 I will take. So 10 and 10 are equals now. For these two equals has to be subtracted. Means -5 I will do. So for the equals are subtracted now. When we do so, the whole or the remainders are equal. How much is 10 minus 5? 5. On RHS also 10 minus 5 is 5. So 5 is equal to 5. Means we are getting the remainders also equal. So if equals are subtracted from equals, then the remainders are equal. That is his third axiom. Fourth axiom is things which coincide with one another are equal to one another. So to understand this, let me consider a line, a straight line. As we studied earlier, their end points, I will write it as, I will take it as A and C, and I will mark the midpoint of this line by letter B. The midpoint of the line AC, I am representing it by the letter B. Now, things which coincide with one another. So here, this line A, starting from A and starting from C, both will coincide at B. That is what we mean by telling B is the midpoint. Yes, no? So, what is this line AC? We have learnt in geometry, no? This whole line AC is now, can I write it as AB plus BC? Yes, it is correct. This whole length of the line AC is sum of this length AB plus sum of the length BC gives us the length of whole line AC. So AC is AB plus BC. So B is the midpoint or the coinciding points for the line AC or A and C, children. That is what the fourth axiom means. Things which coincide with one another are equal to one another. So lines starting from point A, starting from point C, both are coinciding at B, or B is the coinciding point, children. So if they are coinciding at same point B, then they one another are coincide with one another, are equal to one another. Yes, no? AB is equal to BC. Why? Because we said that B is the midpoint. So obviously this length AB is equal to length BC. So things which coincide with one another are equal to one another. That is about the fourth axiom. Fifth axiom states the whole is greater than a part. Whole is greater than a part. Now we will consider the universe and our country, that is India. Okay, so universe is bigger, or our country India is bigger. Obviously the universe is bigger. So our country India is part of the universe. Agree? Our country India is part of the whole big universe. So the whole is greater than a part. Obviously the whole is the universe in our example. So the universe is greater or bigger than the part, that is our country India. Or now we have our state Karnataka in India. So now India is whole, whereas our state Karnataka is part of it. So India is bigger or greater than the part, that is our Karnataka, our state Karnataka. And if you can, one more example means our state Karnataka only, you take it as the whole. Our city Bangalore is a part of it. So which is the whole now? Bangalore city, Karnataka is the whole, whereas our city Bangalore is part of it. Means, what do we understand by all these examples, children? The whole is always greater than a small part. Obviously, it is true. Yes, no, children, all these points what we studied till fifth axiom, it is something which is accepted everywhere, universal. It is a universal truth. Such statements or points are called axioms, children. But postulates are not so. They have to be applied only in geometry. Now we shall move on to sixth axiom. Things which are double of the same things are equal to one another. Things which are double of the same things. I will take two apples. One apple in my left hand, one apple in my right hand. Things which are double the same things are equal to one another. To both the hands, I will tell you to give one more apple. So now I have two apples, that is the double of first one. Two apples in my left hand, two apples in my right hand. Before I had one apple in each of my hands. I said you to double it, means you added one more apple to my left hand, one more apple to me. Still in both the hands I have equal quantities of apples, that is two apples. Two apples, correct? That is what it means. Things which are double of the same things, of course, are equal to one another. Seventh point also similar to this. Things which are half of the same things are equal to one another. See, same old example we shall consider. One apple in my left hand, one apple in my right hand. Now, I ask you to cut the apples, half the apple. So, you will cut half of the apple here, half of the. So, in both the hands I have half apples. So, left hand also contains half apple, right hand also contains half apple. Means, if though you half the things which are half of the same things are also equal to one another. This half of the apple is equal to this half. Like this, any example you can give, children. These are the one example which I gave you in order to make you understand all the 7 axioms given by Euclid. In if asked in test or exam, you can give your own examples in order to explain. Only thing is you should understand the concept, children. It is very easy. These are the 7 main axioms given by Euclid. Similarly, after knowing about the axioms, we shall now discuss his 5 main postulates. So as I said you, postulates are applicable only in geometry. There I cannot explain you considering India, Karnataka, Bangalore city or Apple. Why? Axioms are universally accepted and everywhere it is applicable. Whereas postulates is applicable only to the geometry. It is confined to geometry, children. Next we shall discuss all the 5 postulates given by Euclid.